This is a short disassembly and reassembly guide for FluxScale 600 AC version 2.0. The first thing to be aware of when disassembling FluxScale is that the wires inside are very tight. There's not a lot of room for components to move around, especially the top cover assembly. So you'll see that in a few minutes. The second thing to be aware of is that the glass is secured by two extruded locking bars. Those locking bars at the edges of the fixture here are then secured by 4 screws. In order for the locking bars to come off, all 4 screws have to be removed. So attempting to pull the locking bars off without removing all 4 screws may result in glass breakage. And finally, before we get started, the thread rolling screws that go into the aluminum components, there's 8 of them, 4 on each side. They should be removed and reinstalled a minimal number of times. These are thread rolling screws, and they cut into, well, they roll threads into a aluminum screw boss. And every time we uninstall and reinstall those screws, we chew out those threads more. And so in production, we generally never expect to have to install, uninstall, reinstall more than twice. And throughout the lifetime of the fixture, we generally expect at most this fixture to be serviced once, if ever. So the product is designed to really not to be disassembled many times. So let's get started. So you'll notice I've propped up the fixture on a block so that we can have free access to the end plate. So we're just going to first remove the 4 thread rolling screws. Next up, we're going to remove 3 832 by 1/4 inch screws that fasten the top of the end plate. And here we have the first end plate. So next up, I'm going to flip the fixture over so that you can see the other side. And again, do the same thing. Make sure the end plate is overhanging so that you can pull it off easily. So next, we're going to remove the 2 Phillips head 832 screws that fasten the fan assembly. You may notice that the fan assembly may be a little bit difficult to remove. In that case, then the fan assembly should be the fixture should be set upright, and the fan assembly should be placed downward. So, yeah, you can see I'm having a little bit of difficulty getting the fan assembly off. So I'm going to flip the fixture over. And keep in mind, if you ever flip the fixture over with one of the end plates off, you'll get this. So we don't want the top cover assembly hanging off like that. So if you're ever flipping over the fixture, make sure to grab the top cover assembly and the engine assembly. Oh, and also a note of caution, be very careful around the heatsink fins. They are very sharp. We've gotten cut many times on them. Okay, so I have the fixture flipped over, and when it is flipped over, it's a little bit easier to draw the fan assembly up, and then we're going to pull it off. Next, what I like to do is use a 1mm flathead screwdriver to depress the locking tabs on the waterproof fan connectors. These are 4-pin fan connectors with internal seals, and they can be a little tough to get off. So what I'm doing here is just helping that along by depressing that tab and pulling that off. Actually, it looks like I broke that one. Okay, so fan assembly is off, and we can now remove the other end plate. Orientation of the fixture doesn't really matter when you're removing end plates, as long as there's free access all the way around, so that there's no pressure in the screws when they're coming off. So we'll keep the fixture in this orientation and remove the rest of the screws. Okay, so for this end plate, you'll notice there's this feature where the wires come through. What I like to do is pull the end plate past the jacketing of those wires and then carefully just pull the end plate off of this T-shape opening, which is designed to accept those wires. So now we have both end plates off. The other end plates, keep in mind, are still secured by the AC power connection. We're going to flip the fixture back over so that we can access the LED array. So I'm going to leave the other end plate free hanging. I'm going to hold the heatsink assembly and the top cover assembly, rotate the whole fixture, and not allow the two to separate. Okay, so as I mentioned before, the locking bars are involved in this screw boss. So the threads have a tendency to get chewed up. So if it's a new fixture, like the ones that are being tested at the moment, and they haven't been fastened many times, those threads are probably in pretty clean shape. So you can see this one I'm able to pull out. If you have difficulty pulling the locking bar off, apply a small amount of pressure by hand to the edge of the glass and slide the locking bar off. Now sometimes the locking bars will bind. That is because the thread rolling screws will tend to bind the aluminum together. And so in that case, a little bit more pressure is necessary. So very gently, we're going to tap one of these locking bars off while holding the glass. I'm holding the glass to try to reduce to apply some compression to the seal in the glass to minimize the force that with which the locking bar is held in place with. So I'm just tapping this very lightly at the very edge. Be very careful not to touch the glass. And once I get past about a screw length, I should be able to pull the rest of the locking bar off. Now you can see the glass is aligned in the engine. And what's important to note is that there is a very careful alignment of all the components. There's about a 0.5 millimeter of tolerance between each one of these components in length. And so what that does is it gets us a clean seal across this plate. So we'll talk a little bit more about that when we reassemble the fixture. So after the locking bars are removed, the glass can just come right off. I recommend just placing the glass and being careful not to touch the interior face of the glass. It is sensitive to fingerprints. So from here we have access to the LED array. We would recommend not disconnecting any of the cables inside. So once test instrumentation is applied to the LED array, we can reinstall the glass again. So when installing the glass, it's very important that not only is the ends of the glass flush with the heatsink assembly, and we want to see a very flush surface at both corners of the glass, but it's also important that along the ceiling rails, it is as centered as possible. So what I'm doing here is I'm looking at the alignment of the glass relative to these grooves. So there's these aluminum grooves on this extrusion. And those grooves provide additional pressure to the silicone seal. So what we're looking to do is we're trying to get the glass as centered as possible along this rail. So you can see there's very little difference in the distance from one end to the other, and then from one rail to the other. So now that we have the glass nicely aligned, we can reinstall the locking bars. And so after I've applied the locking bars, it's really important to check for alignment. We want to make sure that these surfaces are as flat as possible. So that's glass to the locking bar to the heatsink assembly, because ultimately this all needs to be compressed, and this is where all the sealing happens. So if you're having trouble aligning these, you may need to give it a little bit of a tap with a hammer to get these in alignment. That is, if those threads are clogging up inside the locking rail assembly. So now that I've got the glass back on, I'm going to flip the fixture back over, and we are going to access the top cover assembly. So in order to do that, it helps to have the heatsink assembly at a lower elevation than the top cover assembly. So what I'm going to do is I'm going to grab the fixture, I'm going to rotate the entire thing, holding both the engine and the top cover assembly. They may separate a little bit, but they do need to be moved and rotated together. Next, what I'm going to do is I'm going to use my block here for that elevation difference that I mentioned. So the AC side is the power entry side over here. This is the DC side, where the DC cables come out of the power supply and go into the engine assembly. So the entire top cover assembly is going to rotate about the DC cables. So we want to put the fixture, the heatsink assembly, the output end of the fixture, at a lower elevation than where the top cover assembly is going to go. And we want that DC side to be facing that change in elevation. So now that I've got the fixture situated this way, you can see I have my AC side facing out. We're going to take the entire top cover assembly, that's this white sheet metal part, and we're going to flip it over onto this slightly higher elevation. And this elevation is really this increase in elevation is going to help us not pull on any of the cables. So take the AC power entry end plate, because it's still attached to the power supply and the top cover assembly. Lift the top cover assembly. Note that there's a ground connection that you have to be aware of. helps to actually remove that ground connection via the WAGO 222 terminal block. So now I've got my end plate, my top cover assembly. I'm rotating it about. Now bear in mind that the fan cables are rather short. There's not a lot of room for them to move. They are secured to the internal duct with a cable tie. But you can see the way I have this situated, I have my engine assembly and my top cover assembly at a higher elevation, and these DC power cables, you'll notice there's very, very little slack in those cables as they go into the engine assembly. So that's why we need to have these components in careful alignment in order to get full access to the entirety of the top cover assembly. So just looking inside, you can see we have the main control module, the Teflon vent on the main control module, the cable glands on the main control module wire harness that then connects all of the internal control and fan cables. We have the two cable glands inside the engine assembly, and then of course the ground connections to the top cover assembly and the engine assembly. So we're going to put this back together. What I'm going to do is I'm going to situate the ground connection for the engine outside the fixture. That way when we get this back together we can reconnect it at the end plate. So what I'm doing is I'm just aligning the top cover assembly back with the slots in the engine assembly. And one thing to bear in mind is that the power supply mates up with the fins with very little clearance. There's really only maybe a 2 millimeter clearance between this heatsink assembly and this power supply. So it's critically important that there's no cables that are underneath this power supply as this comes back together. So you can see my fan cables are nicely aligned so that they're not crushing on that power supply. I'm actually going to go back over here and just make sure that the fan cables are out of the way. And I can see actually that the fan cables have been pinched just then by the power supply. So just do a check all the way around the power supply, both ends, to make sure that there are no cables underneath. Otherwise you'll have a hard time getting the end plates aligned and fastened properly. So we have the top cover assembly reapplied. We're going to make this ground connection back again with the WAGO 222 terminal block. AC power entry. Oh, almost forgot. In order to apply the end plates, we need the fixture at a slightly higher elevation. We have free access to all sides of the end plates. So for the AC power entry side of the fixture, we're just going to tuck all the wiring back in gently. The only wrong way to really do this is if any of the wires are hanging down inside these fins. So we just need all the wires to be above the fins. And there's plenty of space for them to situate themselves properly. So just to hold this end plate in place, I'm going to put one of those fasteners in, and we're going to start the screws. So I'm using a DeWalt. This is one of the cheaper DeWalt drills. And what I'm actually going to do is I'm going to set the torque setting to about a 7. So it's a little bit less than half its range. Just want to be really careful not to apply too much torque And what I'm going to do for now is I'm not going to install the screws all the way. I'm just going to leave them with a few millimeters of threads. So we're not tightening the screws at this moment, because we just want to check everything for alignment before tightening everything. So here I'm just making sure my fan assembly wires are sticking out of the fixture with enough slack to attach the fan assembly. Here we're going to orient the feature, the T-shaped feature, get the jackets of the cables through on this. And then sometimes what you might have to do is you might have to tuck in the DC cables a little bit. You see right here where I'm having trouble getting the end plate on. These DC cables just have to be tucked in just a little bit. So we're actually going to just again fasten this with one screw to hold the end plate in place for now. So now that I've gotten one side, I've got the seals partly compressed in one side. I'm going to go back to the other side just to take a close look at those seals again. And what we're looking for is we want to make sure that the top cover assembly is not pushed over too far to the point where we have trouble sealing. So, because the top cover assembly is very slightly wider than the heatsink assembly, that is to make up for the seal thickness when it's compressed. So, again, I'm just going to tighten up the screw a little bit just until it starts compressing the seal. Same with the rest. Again, making sure everything looks like it's in good alignment. So you can see we just started to see a little bit of compression down there, closing the gap. We're going to do the same thing on the last two screws. Just watching that seal as it draws in a little bit. Then getting that last screw drawn in to just start getting the seal. Okay, next what we're going to do is increase the torque a tiny bit and tighten all the screws. So I'm going to go on my DeWalt and increase it up a tiny bit, again only to about halfway the torque on this, and this is a relatively low torque consumer model. So now that I've reinstalled all of those screws, I'm just taking a quick look at the seals to make sure that we have nice uniform compression along the length of the seal. So you'll see, you can see the signs of compression along the length of the seal. Where the locking bar meets the end plate on the face of the fixture, you can see the seal is compressed. And then if we look into the edge of the glass, you'll notice, you can see that there's a small amount of compression along this edge. So this is a nice indication that we have a good seal across the surface of the extrusions and the glass. So just taking a quick look at the other side here. So one final note on the main control module. There's a seal in the main control module cover, and a minimum amount of torque must be applied to these screws in order to fully seat that seal. So you can see the seal is inside this plastic lid. We typically hand tighten this. So what we're looking to do is just secure all 4 screws first, and then go back and hand tighten. We're not using torque control in this case, but what we are looking at is ensuring that we just start to deflect the edges of the main control module.